Hello, my name's Pamela Norris. I've been at VMware for 9 years, being a vExpert for the past 3 years, and of course, now a Avi vExpert. Trevor?
Thanks, Pam. My name is Trevor. I am a staff SE here at VMware. First focused on NSX for a long time, and now I work on the Avi platform.
Great. So today in today's NSX ALB discussion, also formerly known as Avi, we're going to be talking about doing L4 and Ingress within a TKGm environment. So when we're talking about Avi, which is considered a modern day load balancer, also known as, Generation 3 load balancer, and Avi Enterprise, which is what we're going to be covering, we're really going to be talking about how you can add value to your Kubernetes deployment. It's important to note that AKO can be supported in a wide variety of Kubernetes environments, including vanilla Kubernetes, OpenStack, some managed Kubernetes, such as like EKS and AKS, et cetera, as well as Tanzu Kubernetes Grid, M and S. And obviously, we're going to be focusing on S today. We're going to be focusing on M today. Now, this list of the Kubernetes distributions that we support is ever evolving. So you're going to want to make sure that you look at the most recent compatibility guide to get the most up-to-date list on who we support. So just a quick review of what we're going to be doing today. We're going to just do a quick touch base on what TKG is, the pain points with the traditional, L4 and Ingress solutions out there, touch on the Avi architecture, how we feel Avi can add value, followed by we're going to be handing it off to Trevor for a demo. So if we look at containers, we sort of have to, look at our TKG in general, we have to take a step back. So first, containers came on the scene really with Docker around 2013. This concept that you can have not only applications, but bits of an application running in individual containers, which gave you a lot more flexibility. All of a sudden, you had this ability, let's say, to update a portion of the application without having to update the entire application, making it much more easier and effective to do so. And then fast forward a little bit, we had, Kubernetes, come on the scene. And what Kubernetes allowed you to do was cluster hosts, making them a lot easier to manage those Docker containers. And then fast forward to today, where we have things like Tanzu Kubernetes Grid M, for example, where all of a sudden it's allowing you to do things like deployment consistency and automated, cluster functions. So if we take a step and look at what is the problem with today's, solutions. Well, in frankness, there's a lot of them, right? If you have your L4, okay, great for layer 4 load balancing, you're going to be maybe doing, L5 or Metal LB. If you're talking about Ingress, also known as layer 7, load balancing, stuff like Nginx and Contour. And oh, wait, we need more. We got WAF, maybe Imperva or Radware or ModSec, depending on what approach you want to take, and DNS and IPAM. And you also still need to add GSLB on top of that to do your load balancing between your clusters as well as your sites. This gets really expensive, from a licensing and support cost, having to manage all these different environments. When you go to implement on day one, you're going to have to implement all these individual solutions, even to get your cluster up and running. And then you're going to have to integrate them with each other, which, as everyone knows, some of these solutions are a lot easier to integrate than others. And then also in separate management, every time somebody needs, let's say, a new virtual service or VIP of some sort, you may be touching 2 or 3 of these different solutions, just trying to get them to work together. And then when you want an idea of what that flow is, you're going to have to log on to each of these individual, solutions. And gosh forbid, if you have to troubleshoot and determine what the flow is, you're trying to piecemeal these things. And what we're finding is a lot of times we're getting brought into those conversations, because initially people are like, this isn't so bad. I got a little small POC. This is doable. But very quickly becomes evident, having all this dispirited solutions out there isn't really scalable. So that's where sort of Avi comes on the scene. So if you look at Avi had the advantage of when it was built, these concepts, such as containers and even clouds, et cetera, existed. So we had that advantage to incorporate that into our solution versus the legacy where they just sort of had stuff add on. One of the first things we did was we separated the control plane from the data plane. This is going to give us an enormous amount of flexibility that we're going to get into in a second. Let's talk about your controller. Your controller is going to be where you do 100% of your configuration, your orchestration, upgrades, etc. You actually never touch the load balancers to manage your load balancers, which is kind of crazy. Because what ends up happening is your load balancers that are also known as service engines within Avi are running at the data plane level. Essentially, they're just bots. What ends up happening then is when you configure your virtual service, also known as a VIP, from the controller, it pushes down that configuration to memory. Now, if we're looking at where they're running, it almost can literally be run anywhere. Bare metal within a Docker container, or virtualization. Maybe we're talking on-prem with vSphere or KVM, or even one of the public clouds, and even containers, which of course is why we're here today. It's important that don't run in these environments. We're integrated into those environments. And why that's an important distinction is all of a sudden now a lot of that heavy lifting that has to be done for the solutions to talk to each other has actually been done for you. We have our centralized orchestration. This can't be underestimated. Not only are we talking about everything's done from the controller, but let's say, for example, right here, if this was an SE group, which is a logical grouping of SEs, also known as load balancing, this guy could be running, some in a Docker container somewhere. Maybe this guy is supporting, some EKS. And this guy over here is doing some vCenter, on-prem load balancing, all managed by the controller, all within the same fabric. And then elasticity. When we're talking about scalability, Avi can scale out natively to 4. If you're using BGP with the ECMP, we're talking about 32 plus, depending on what you're pairing with. And also now with Avi, you have the ability to expand and contract on the fly, either manually by clicking on a button in the GUI, or maybe making an IP or API call, or even doing it, automatically with a feature called auto rebalance, which is more along the lines of like CPU and TPS. Again, almost completely transparent to the user. And then resilience. Let's talk about when something goes wrong. If we talk about the Avi controller, typically on the on-prem solution, it's going to be in a controller cluster of 3. Or even on public cloud, if you're dealing with the customer managed, it's still typically going to be 3. 1 dies, who cares? 2 dies, it goes into a read-only state. Your entire controller cluster dies. Yeah, it's bad. You're not going to get your analytics. You're not going to be able to make configuration changes. But the amazing part is because the control plane and data plane are separated, your load balancers are can continue to load balance. And then let's talk about what happens if an SE fails. Well, if an SE or a load balancer fails, what will happen is, if you might have seen in that little graphic, is it's actually going to go in, detect the failure, send an API call, spin up another VM, start the services, and the controller will push down the configuration, all without administrative intervention. And then automation. To this day, Avi was founded, and now fast forward to today, every feature is API first. So what that means is all of a sudden, traditionally you'll do something within the GUI. Great, I want to automate it. Can I? With Avi, we don't have that problem because every single feature we create is built on the API, making us incredibly easy to use when stuff like Ansible or Terraform or even the Snow integration. And analytics and observability. Traditionally, analytics are incredibly expensive from a CPU and memory perspective. And so since everything's on the control plane and data plane in a traditional load balancer within the same device, you're pretty much limited to a TCP dump unless you invest in a very expensive third-party solution. Within Avi, because our load balancers are load balancing, we have the resources available to do those deep analytics within the controller that are really second to none. And Avi Pulse. Avi Pulse is, think of your like phone home sort of solution. You can configure it in various ways, including, if you're doing WAF, automatic signature updates, automatic IP reputation. We now have proactive SE or SRs or support requests that can be open for you now is in tech preview. And then we continue to enhance that line. So now let's get why we're all here, right? The Kubernetes integration. The first thing you're going to notice right here, let's get over here, is this is going to be your Avi Kubernetes operator. This is going to be what's installed within a pod in your cluster. It's going to go in and it's going to work with the Informer framework within the Kubernetes cluster to automatically create stuff like ingress and routes and services. Because what ends up happening then is the Avi Kubernetes operator detects what is going on and then reports back to the controller, and sort of think of him, or that person as an interpreter, reports back to the controller, and then the controller will then go in and automatically create those virtual surfaces for you. This is really giving you full lifecycle management, because all of a sudden now, anytime you create something, delete something, update something, it's automatically happening for you without an additional, manual calls within that load balancer. And this is an example of TKGm 1.3 with vCenter that has no NSX. So what's going to happen is you're going to install your AKO within your management cluster. And then what's going to happen after that is every time a workload cluster is deployed, AKO is going to automatically create another account that's going to talk to that, be able to allow it to talk to the Avi Kubernetes cluster. And then it's going to also do stuff like it's going to automatically configure an L4 service type with in node port mode. You can actually go in and change it just from node port mode if you want, but that's what's going to be default. You can also go through and do an additional configuration to allow for L7 ingress. Now, it's important to note that the SE group, which again is the grouping of service engines, by default is going to be shared. The default SE group is going to be shared across the Kubernetes clusters. You can go in and change this action once the initial deployment of AKO has occurred. If you're doing node port or node port local, you definitely have the option to share SE or SEs within the same SE group across clusters. If you're going to do the controller cluster, you have to do cluster IP, then the IPs have to be routable between the individual clusters in order to share the service engines. And one other last thing to note is what ecosystem you're going to be installing AKO in is going to definitely affect what configuration you do and how you go about doing it. So you'll want to make sure that you consult your installation guide for the particular environment you're deploying it in to make sure that you have the most accurate information. And I also wanted to touch on multi-tenancy. So within Avi, we support full multi-tenancy along with RBAC controls and granular RBAC controls to really isolate the workloads between tenants when needed. So this may be you want to isolate your load balancers between clusters, or let's say you have Avi already within an enterprise and you don't want your enterprise workloads to be affected in any way by your Kubernetes distributions. You can absolutely do that with no problem. So Trevor, I'm going to go ahead and hand it off to you.
Awesome. Thank you, Pam, for the overview there. Now what I'm going to do is take us through an end-to-end installation of that Avi Kubernetes operator that Pam was just telling us about, okay? I'm going to walk us through the initial install, and then I'm going to set up both a layer 4 load balancer and then a layer 7 load balancer and explain some of the differences. But the point is really to show you how simple it is to get AKO up and running in your Kubernetes environment. So here is my Avi controller in my lab environment. As you can see, I do have one prerequisite that I configured here, which was I put a DNS virtual service in place. That's because in Kubernetes, when you configure a load balancer or an ingress, you oftentimes also need to publish a DNS record, okay? So I've let Avi be authoritative for the subdomain, so that way, whenever we create our load balancer, whether it's a layer 4 or layer 7 ingress, we'll actually be publishing DNS records and automating that function through AKO, okay? I also have, just from a topology perspective, 2 networks we're using. One is a network for my Kubernetes nodes, and then the other one is for the actual VIPs, so the IP addresses that we'll be pulling and using to deliver traffic to our application. You can see right now I don't have any routes configured. What's going to happen is when I install AKO, these routes are going to be automated because I'm installing AKO in what we call a cluster IP mode. And so when we do that, we inject static routes to reach our pods. So I just ran a quick show command. You can see that we do not have any AKO pods running. In order to install AKO, what we need to do is edit this values.yaml file. So if you follow our install docs, you can go through this process. And if you're installing TKGm or TKGs, a lot of this process will also be automated. Okay. I have my values filled out in here for me, like the fact that I'm using cluster IP and the names of my various networks that I just showed you in the previous screen. Okay. So I have my YAML file filled out. I've got a controller and I've got a Kubernetes cluster. So all I need to do now is run my Helm install command, and I'm going to reference that values.yaml file that I just showed you. And what's going to happen is AKO is going to spin up the AKO pod in this cluster, and it's also going to reach out to my controller to do some of that initial configuration. So as you can see here, I do now have my AKO pod. It is creating. We'll give it just one more second. Cool. So AKO is up. It's online. Now I'm going to just pop over to my controller to make sure that AKO was able to hit it and configure those static routes for that cluster IP mode that we were just discussing. Looky there. So we now have our routes in place. And again, these routes are key because these are the pod networks, and the next hop of these routes are the actual node IPs. And that's what allows us to get reachability into the pods, even though they're not advertised publicly out onto your network. All right, so I have my prerequisites in place. AKO is installed. Now is the fun part. I can start provisioning some applications. So the first thing that I'm going to do is I'm going to run some kubectl commands against an application that I have saved here. So you see this Kubernetes manifest YAML file. I'm going to go ahead and reference that file in kubectl. And what that's going to do is launch a test application that is front-ended by a layer 4 load balancer in Avi. What you'll see whenever I run the command is that while I have no load balancer sitting in my Avi controller right now, as soon as I run that command, I'll have an application online. And I'll also have that load balancer be configured within my Avi controller. So let me run my kubectl command here. I'm going to reference that manifest file. All right, so all of my pods are spinning up right now. We'll just give this a little bit of time as the application comes online. But you can already see that the load balancer in my Avi controller has been configured. So this is there. Now it's just waiting for the pods to spin up and come online. So that way we can turn green when the health checks are successful and start forwarding traffic. So we'll give this just a second to bring that application online. You can see in my cluster, some of these are still in the create process. So give them just a moment. All right, excellent. All of my pods are now online. So I should see a healthy load balancer right here, which we can see I now have a load balancer configured in my environment. And this load balancer, it's not just a load balancer, it's a full web application that we deployed with that manifest file. So I'm just going to navigate to the URL that we defined in that file, and now I can access my application. So in just a few minutes, we went from a brand new Kubernetes cluster to a load balanced application within my Kubernetes environment, and that's what we're accessing right now. Now, right now, this is only doing layer 4. Okay, we are not engaging Ingress at this time, so that means we miss out on some of the key benefits and features of what Kubernetes can do from an Ingress perspective, but also what Avi can do as far as delivering additional layer 7 services to your application. So my very next step is going to be taking that same application, but instead of configuring the layer 4 load balancer, I'm going to front end that application with a layer 7 ingress. To do that, I'm just going to reference my ingress file here in my cluster. Cool. So my ingress has been created. Now, if I go back to my Avi controller, we should see that my ingress is spinning up and should soon come online. All right, so now my ingress is healthy. So what this means is that before we were just doing layer 4 load balancing, kind of just spraying traffic across my web pods in my cluster. But now we can actually terminate the HTTP and HTTPS sessions onto Avi. And that allows us to get some additional visibility into the application. We can also do things like content switching, redirections of traffic, maybe engage a WAF policy. We can start taking advantage of the more advanced features in Avi when we start engaging layer 7 services in our application like an Ingress. So I'm going to click around my app here just to create a little bit of traffic because the next thing I want to show you is how when we use Avi as a layer 7 Ingress, we're able to take advantage of some of the data and analytics that Avi collects by default for a layer 7 app. So I clicked around my app a little bit, and you can see here in my logs all of these various transactions that are listed here with the different URLs. That is the traffic that my client was sending into that application. So I can open up those transactions, see what's happening inside, see what Avi is doing to that packet, whether I want to troubleshoot, what backend server it's being sent to, or maybe there's some other application behavior I need to view or visualize and troubleshoot in my environment. All of that data is available here with Avi Analytics. I can even go as far as to debug the headers that are being added and removed from this application by my Avi load balancer. And this is all just native functionality of Avi functioning as an ingress for your Kubernetes environment. These logs certainly help whenever you're developing things and trying to figure out how to deliver application services to your pods. But it's also great even once those applications move into production because we are generally developing web applications at this point in time. And it's really critical to be able to see inside of the traffic to troubleshoot those applications in real time when there's some kind of slowness issue, or maybe an end user has submitted a trouble ticket with the application. This gives us a really clear view into the end user experience for the applications that you're hosting in your Kubernetes cluster. That's really all I had to show here. I wanted to take you through not just the AKO install, which as you can see takes only a couple of minutes, but I also walked through how we would provision a layer 4 load balancer with AKO and also a layer 7 ingress with an AKO. So thank you very much. I'm going to pass it back to you, Pam, to wrap us up.
Thank you very much. Let me go ahead and share my desktop. So thank you guys for listening to us today. We just wanted to make sure that we shared some information on where you can go for more information. The first off is Avi has a wide variety of free webinars out there. They're continually getting added to the calendar. We have everything from a 4 half-day deep dive within the Avi architecture to 101s to AKO, GSLB, you name it. Also for particular instructions on how to install Avi, you'll want to hit the Avi installation guide or the AKO installation guide, which is referenced in this slide. And obviously, you can always reach out to your VMware sales team. They know how to get a hold of us, and we'll be more than happy to have those discussions with you. Thank you for your time.